In this video, I would like to demonstrate the new features that we launched in the new version of SystemairCAD called C2024-04.29.K1, released here in April 2024. One of the new features is Geniox Side-by-Side. In the new Select Unit Type dialog, you can see that there's a new icon here for Geniox Side-by-Side units. If we activate that, we can see that the text up here in the top changes to top view, and that means that we see all the templates from top down. As in Geniox, you can select rotary heat exchanger, plate heat exchanger, runaround coil systems, single flow, and mixing units. It is also possible to select outdoor units, but hygienic is not available so far. The side-by-side unit comes in 11 unit sizes. And if I just punch in a low air volume down here, you can see all unit sizes in this diagram, going from 1206 to 3216. The names are like the modular width, 12 modules or 100 millimeters, that's 1200, and the height is 06. That means 6 modules, 600 millimeters. The width is always defined as a double width. That means that you have a heat exchanger side-by-side unit. Let's do a configuration. If I take 5000 cubic meters an hour, I do a rotary heat exchanger just with a heating coil in a size 2010. A size 2010 is 20 modules wide plus the post, the width of the post, that's 82 millimeters, so 2082. And if we look at the height, then it's 10 modules or 1082, because again the post is 82 millimeters. Then we have the height of the base frame, and totally the unit is 1200 with this 1800 millimeter base frame. When you navigate on the unit, it's a good idea to use these pre-configured views down here. They give some advantage for dimensions. For example, if you go to top just by rotating, you cannot see any dimensions. But if you use the top view, then all dimensions will be in the right position. And also when we use this top view and insert function from this top side view, then you will see that the handles are placed neatly here on top of the unit so we can see them. So now I inserted an inspection section, and of course as in Geniox I can increase that length to 400 or 500 if I want to. I can also insert a cooling coil after this inspection. When we have a single wide, as you can see here, it's the same system as we have in Geniox. So when the supply air section is much longer than the extract air section, put on the extra functions here as single high, or in this case single wide. And of course, as in Geniox, you can always place a empty section in the extract air if you want a square unit that you can lift in one operation. Now we see that it is double wide. It is placed on one base frame, so it can be delivered in one piece. We also have several options when we are going to the rotary heat exchanger. Normally we have one echo size, but here we have up to 3 in some unit sizes. Here we have 2, because the diameter of the rotor is of course an issue. When we have such a small diameter rotor, we will have a high pressure drop and a low efficiency, and in the end it will mean that the performance of the unit will not be very high. We need a low air volume to stay within echo design. So therefore we can extend the height of the rotary heat exchanger section, and by doing that get a larger rotor, a larger pressure drop, and better performance. Let's go back again. like that. This configuration can of course also be configured with roof. If we add a roof, then we can see that it is sort of like a black fat line here at the edges of the unit to indicate there is a roof, but it's done like this to keep a view over the functionality and the configuration of the unit in this top view. Another new feature when we talk about control system is this possibility to place it on the back side of the rotary heat exchanger if you want integrated control system. If we check the rotary heat exchanger section, you can see that we actually have got the control system here on the back side of the rotor, and that's of course because it's very convenient. We have a lot of space because of the huge width but low diameter of the rotor, so there's plenty of space for the control system. So in this case you can enter the control system from we can't even call it the back side, the inspection side or this side, and we can service the rotor from this side. There's also another new option. So if I go to the back side once again and say move function, I can see that there is a handle up here in the top, sort of floating outside the unit, and this is for the control cabinet to be mounted on the wall. And if I double click the cabinet, I can see that I can get it with an extended cable of 5 meters, 10 meters or 15 meters. Otherwise, the functionality of the control system is exactly as Geniox Basic. We have the same options, we will get the same documentation, so there is no difference in the selection. Of course also, what can we say, accessories can be selected from this. For example, duct connections, if we want a 20 millimeter duct connections. One thing that we should also notice is that we can select the casing in several materials, and if we do that, we can of course also get the black duct connections. You can also see up here that we actually have both Geniox and Side-by-Side, and if you select regular Geniox, the system will convert what we have done to a regular Geniox. I can even go back. I also have an icon down here where I can go back to a Side-by-Side. Let's say it's not able to handle everything automatically because it does not know that you had this external control system before in the wall-mounted version, so it goes for integrated as it was in the basic configuration. But it is a possibility to switch forth and back between configurations. We also have counterflow heat exchangers in Side-by-Side. Here we have a very wide counterflow heat exchanger. That's actually a difficult thing to see, but you can see here that goes full width to have as low pressure drop and high performance as possible. Again, here you can see the integrated control system, and I'm also able to move it to the wall-mounted version on counterflow heat exchangers. Of course, I cannot place the control system on the back side because of the heat exchanger goes in full width to have as low pressure drop and high performance as possible. Let's try and calculate. Here we can see that we get decent values for this Geniox 2010. You can see we have a heat recovery at 88.3, and we have a SFP value of less than 1.6. So the values are actually quite good, even though the heat exchanger size is not that big. If we check energy, we can also see we are actually quite far from the limit air volume wise in this Geniox 16. If we go to the printout, let's just do a regular printout long technical specification. It is also as the, what can we say, standard Geniox printout. All data are exactly like the regular. Drawings are a bit different because it has been a challenge that we have to see the inspection side, of course, from both sides. So the views are turned 90 degrees, so they are vertical. And then you can see the both ends of the unit, both inspection sides of the unit down here as well. Base frame as usual. And if we go further down, there's one detail that is a bit different. Control system is the same as we use for Geniox, with the same IDs, same controller, same everything. If we look at the heat exchanger, we will have several pressure drops. We can see that we have a pressure drop, dry conditions, 154, but we also have a total pressure drop of the section, 185. That's because the air distribution is a bit difficult in a side-by-side unit. If we check the 3D model, like that, and the top view, then of course we know that the airflow has to go from this side of the unit through the heat exchanger in the top level, down through the heat exchanger and out through the bottom level and into this fan out here. And that air distribution is quite difficult, and then it adds a bit of extra pressure drop. So that's why we have the second one. So the difference between the 154 and the 185 is actually system pressure drop added to make the data fit. Otherwise, printout is as always. The next new feature I would like to demonstrate is the new heat pump defrost free. And here we can see that we added a new icon for the new heat pump, and the difference is clear here, the template. You can see in the old heat pump we have the rotary heat exchanger in between the two coils, and that's to optimize the unit for cooling recovery as well. This new defrost free is mainly for heating, and then you get the benefit of also having a cooling capacity available, but it is mainly for heating. So let's select the Geniox 16 with 7,200 cubics a minute. Immediately we can see that the unit is with control system. It is not possible to select the heat pump defrost free without control system. We can also see if we double click the heat pump, then the rotary heat exchanger selections is included, and it looks a lot like a rotary heat exchanger dialog. And also if we close or open the rotary heat exchanger dialog, we can see that it is the same dialog. So the rotor and the heat pump is considered as one heat recovery unit. And that is also why that the defrost free heat pump can only be delivered in combination with a rotary heat exchanger. In the dialog we have the usual rotary heat exchanger types available, also with the 4 different efficiency classes. We are able to force the selection of a boost heater inside the heat pump. That's an electrical heating coil that can help a bit if the outdoor air temperature becomes too low and we cannot obtain the requested supply air temperature. We can also select or force the selection of a drop eliminator in this dialog, but they will both be added automatically if they are needed. So let's just check our temperature settings. Minus 1290 in the winter, and now we focus on winter because it is for heating. We have 2240, and let's see what happens here. we can see that the supply air temperature was not reached in cooling mode. We only get to 15.6, and why it's 15.6? It's because of that temperature and humidity. It expects that we will add 0.4 degrees in the fan section. But what it could obtain after the functions is 17.3, and when we have 17.3 after the heat pump, then we will get 17.6 in the supply air temperature. That's what is up here. We can see that we have capacity enough for winter, where we can heat up to 22 degrees. So if we check the drawing here, we can see that there's no boost heater added. The boost heater will be placed here in front of the coil, in between the coil and the rotary heat exchanger. If I, on the other hand, change the outdoor temperature, adjust the winter humidity to a more realistic level, then I can see if I calculate, it says to me that the supply air temperature is still not reached in cooling mode, same temperature as before. But if I go back and check the configuration, I can see that it actually added a boost heater to obtain the 22 degrees. Let's go to print and preview. If we go to the heat pump section, we will also see that it is defined as the Geniox HV defrost-free and boost heater now, because I have a boost heater, and the rotary heat exchanger is also included in this heat recovery section. I can see the efficiency of the heat exchanger and also what kind of heat exchanger we are talking about. But otherwise, we have what is a heat recovery data is actually combined data for the heat pump and the rotary heat exchanger in winter and in summer. If I check some of the data, I can see in this case I have a COP value of 7.7. I use the full capacity of the heat pump, and that's also why there's added a boost heater. The absorbed power of the heat pump and of the boost heater. Then here during summer, I can see I have an ER value of 3.1. I use 13.5 kilowatts in the operational point. Yeah, and I can of course see temperatures and humidities before and after, like I can for any other function in the printout. Let's go back to the unit. So let's spend a minute to look at the default configuration here. The heat pump defrost-free is optimized to be as short as possible, so all sections can go through a standard door. And here we can see that the heat pump section is 900 and the other sections are below 900. There is also a rotary heat exchanger of 400 millimeters, and that of course costs a bit extra to have this division of the sections. So we have 4 sections in total in the unit. But if it's not needed to go through doors or there's no requirement, then of course we can go to manual casing and combine the section, so we only have 3 sections. Another new feature that we implemented is the upgrade of cylinder filters, carbon cylinder filters. So let's select the Geniox 18 and put some carbon cylinder filters in the end of the unit. The amount of cartridges in the sections is increased to increase the maximum air volume of every unit size. We also implemented a longer carbon cylinder, so the type CT3500 is implemented, and that will also contribute to what can we say, increase the maximum air volume of every unit size. and still be within requirements. The next new feature we implemented is an update of the access controller from version or generation 4 to generation 5. Here we need to take attention because the two versions of the controllers are not fully compatible. The Modbus and BACnet protocols are updated, and addresses for the variables are changed. So we need to make sure that the hardware we deliver, the controller we deliver to the customer, is according to the documentation that we deliver to the customer. So if you have a unit that is configured in an old unit, let's see, I should have one generated in J9, and yes, it is in J9. Then I actually get the option to say, do you want to update the controller to a 5.x? Because this is of course with 4.x, because that was the standard in the last version of SystemairCAD. If I do not update, then it will continue the 4.x controller. If I say yes, then the system will be updated. And this is of course because if you have partly delivered something to the customer, or you deliver documentation before you transfer the order to M3, then the generation of controller and the documentation will not correspond. So we need to think careful what we say when we update former quotations or orders, that the customer actually gets what he needs. So if I say I would like to update, so now everything should be 5.0, and if I look at the drawing and say control system, then I only have the new dialog available. The old, more compact with less options is phased out. It is very alike. There's a bit more options here, and there is a separate video where we go through this control system dialog. It is also here where you can see the flowchart. You can rename your sensors, you get a component list, and so forth. But we selected a 5.x, so let's calculate. And go to print and preview. Let's just take these Modbus and BACnet protocols as a printout and see what happens. And here you can see that it is actually selected as 5.0. If I did not update when I opened the file, I will get documentation for 4.x. When we are at control system, we also had a feedback from many markets that it was not correct that the flowchart did not follow the orientation of the unit. Here we could see we have a right side inspection side, and it is the same here in the flowchart. So if I go out and say now we change the side of the unit, go back into the control system and look at the flowchart, we can see that the flowchart is actually corresponding to the unit configurations. But this was what I would like to show you for this new version of the SystemairCAD. So thank you for listening, and I hope you will enjoy this new version. Thank you.